Hey everyone, thanks for coming out. This talk has a little bit of a clickbaity title, but I'm going to be talking about magic methods in Python in this. My name is Darshan Markandeya, and I work in the backend engineering team at Venmo. And if you want to reach out to me, you can. There's my Twitter handle and there's my email address. Two quick notes before we start. If you want to follow along with the slides, you can go to the bit.ly URL at the bottom of the slides. That is bit.ly/magic-off-python. And if you have any questions, I'm going to be around at the end of this talk. So feel free to come up to me and talk. So here's a look at the agenda for today. We will start off by going over what magic methods are. We will then enumerate over 3 groups of magic methods, looking at some code samples for each of them. We will then look at abstract base classes from the collections module. We will end by taking a look at context managers. What are magic methods? The word magic makes these methods seem like they're a little bit more complex than they are. And the Python documentation refers to these methods more as special methods. You can also hear them referred to as dunder methods, which stand for double underscore methods. It's likely that you have used some magic methods already. For example, you've likely used dunder init to initialize classes, or you've likely used dunder name. And in this talk, we'll be going over a range of them. We'll be going over 3 groups of magic methods for the bulk of this talk. The first one let you define custom behavior. The word custom here is a little bit overloaded, but I'm talking about methods that let you represent what the hash value of your object should be, or let you represent how your object should look when it is printed out. We will then look at magic methods that let you enable operator overloading. For example, you can define how your object behaves when the plus sign is used on it, or when the comparison operators are used on it. We will then look at some magic methods that let you emulate built-in types. So for example, if you want your object to behave like a list and offer indexing behavior or slicing behavior, you can implement some magic methods. Similarly, you can have your object offer dictionary-like behavior as well by implementing some magic methods. Here's a contrived and simple shopping cart example that we're going to iteratively add into for the rest of this talk. So there's a base cart, and there's in the constructor we simply pass in a user ID, and there is a cart underscore items dictionary. It's a mapping of item ID to item count. And if you want to add an item into this cart, you would call the add underscore item function. It takes in an item underscore ID and an optional item count. And all it does is it adds it into the cart underscore items dictionary. If I were to use it, I would instantiate it like this. I'm instantiating cart underscore 1, and I'm adding an item into it. And when I print it out, I see the default representation for when an object gets printed out in Python. You're seeing the name of the class along with the memory location for that class. Here we can transition into the first group of magic methods. These will let you define custom behavior for your objects. For the example output that we just saw, let's see if we can add more information when an object gets printed. And to do this, we can use the dunder wrapper and dunder str magic methods. They are closely related. Dunder wrapper is intended to return an official representation for your object. The convention here is for the return value to be a valid Python expression. So you'd be able to copy that back and paste it into your IPython terminal while you're doing something like debugging. Similar to dunder wrapper, you can add a dunder str, which is a more human-readable representation of your object. If dunder str is not implemented, Python falls back to the implementation for dunder wrapper. So let's add it into our cart class. Here you see the implementation for dunder str. I'm simply saying, hey, there's this cart for user ID with this many items. And you can see the implementation for dunder wrapper has the name of the class along with the argument used to instantiate an object. So now if I were to create a new cart object and I add some items into it, when I call cart1 in like a Python shell or an IPython shell, I see dunder wrapper getting called. And when I call the print function with the cart_1, you can see that my implementation for dunder str gets called. We can also see that when you use this object within string formatting, the dunder str magic method gets called. You would add a dunder bool magic method if you want to compute the truthiness of an object. So if you add this, you can use your object in conjunction with an if statement. So this implementation is simple. I'm simply returning true if there is at least one item in the cart_items dictionary. And now that I've added dunder bool, I'm able to do things like this. I'm instantiating a new object, and I'm adding an item into it. I can do things like this, where I say, if cart, do some operations, or else do something else. And we see that the first if statement gets entered because we added one item into this cart object. There are many other customization methods, and here's a look at just a couple of them. Dunder hash lets you define what the hash value of your object should evaluate to. Dunder del gets called when you use the del keyword on your object. A quick note here is that the code within dunder del doesn't get called right away, but it gets called when the reference count for your object goes to 0. We'll now look at some methods that enable operator overloading. And the first one is dunder GT. Implementing this magic method lets you support comparison for your object. So if you want to check if your object is greater than another, you would implement this magic method. Here in this example, self refers to the operand on the left-hand side of the greater than sign, and other refers to the operand on the right-hand side. And here I'm returning true if there are more items in the object on the left-hand side than the right-hand side. And with that, when I create 2 new instances of the cart, and I add one item into each of them, I can do cart1 greater than cart2, which evaluates to false, because they each have one item within them. And when I add one more item into the first cart, and I call that expression again, this evaluates to true. There's a whole range of these magic methods that let you enable rich comparisons. So if you want to define the behavior for the lesser than sign, you would implement dunder LT. If you want to define the behavior for equality checks, you would define dunder EQ. So you can see that implementing all these methods for every class that you write can start getting tedious. So there's a convenient decorator called total ordering in the functools module. If you add this decorator to your class, you only need to implement dunder EQ and any one of the other comparison methods. Let's take a look at an example. Here I'm importing functools from total ordering, and I'm adding that total ordering decorator as a class decorator to my cart. I provided the implementation for dunder GT and dunder EQ. We saw equivalent, an example of this earlier. And with this, when I again create 2 new instances of the cart and I add items into both of these cart objects, I can do things like this. Here I'm checking if cart1 is lesser than cart2, even though I have not explicitly provided an implementation for dunder LT. Similarly, I'm checking if cart1 is greater than or equal to cart2, even though I've not provided an implementation for a dunder GE. This magic method lets you define the behavior for when the addition sign is used on your objects. Again, in this example, self refers to the left-hand side of the addition sign. Other refers to the right-hand side of the addition sign. I'm creating a new object with the user ID of the left-hand side, and I'm simply adding items from both of the cart objects into this newly created cart. And finally, I'm returning that newly created cart object. And with this, when I create instances of the cart, again, add items into it, I can do things like this. Here, I'm saying cart3 is equal to cart1 plus cart2. And underneath the hood, we are calling dunder add. And when you print out cart3.items, you're seeing that there are 2 item ID 1s and 1 item ID 2. There's all the expected methods that you would want. So for example, if you want to define the behavior for the minus sign or like the multiplication sign, you would implement all these magic methods. And there's also the reflected equivalents of these. If you want to define behavior for the arithmetic operations that we saw earlier with swapped parameters, you would use these reflected methods. There are also methods that let you enable unary operations. So if you want to define the behavior for your object when the absolute function gets called on it, you would define dunder ABS, and dunder neg and dunder POS would provide implementations for when your object is prefixed with a negative sign or a plus sign. There's a whole range of these, and you can find a link to them in the documentation. The last group of methods that we look at let you enable container types. So one thing here is like containers in Python can be of a few different types. For example, they can be sequences similar to lists or strings or tuples, or they can be mappings similar to like a dictionary. For the example cart class that we've been looking at, we'll be treating it as a mapping container. You might want to get the number of items in your cart object, and to do this, you might maybe like add like some function like get item count to your class's definition, or you might call the len function directly on the cart_items dictionary. An alternate to this is by adding the dunder len magic method to your class's definition. Here in this implementation, I'm simply returning the sum of all the values in the cart_items dictionary. And now that I've added this dunder len, when I create an instance of the cart and I add a couple of items into it, I can call the len function directly on the cart object itself. And here you see that it evaluates to 3. If you want to define membership checks, you would implement dunder contains. You would use this in conjunction with an in statement to see if a value is present in an object. The implementation here, again, is pretty simple. I'm simply returning if a key is present in the cart_items dictionary. And with that, when I create an instance of the cart and I add some items into it, I can do membership checks. I'm checking if item ID 1 in cart, which evaluates to true, and item ID 2 in cart evaluates to false. If you want to iterate over your container, you would implement the dunder iter magic method. And to understand this a little bit better, let's take a quick look at how iteration works in Python. For iterating over an object in Python, that object needs to follow the iterator protocol. And to understand that protocol, we'll need to understand 2 things. We'll need to understand iterables and iterators. Iterables are anything that you can use in a for loop. So for example, lists, strings, tuples, these are all iterables. Calling the built-in iter function on an iterable needs to return an iterator object for that iterable. So what is an iterator object? This is the object that takes care of going through each element within your container one by one. You can call the next built-in function in Python on this iterator object to get each element within the container one by one until you reach the end of the container. Let's take a look at an example, and that will clear it up a little bit. Here, we have a simple iterable as a list of 2 elements. And when I call the built-in iter function, I get back an iterator. You can see that when I print iterator, I've got back a list iterator. And when I'm calling the next function on this iterator, I get the first value in the list, and then I get the second value in the list. And when I reach the end, a stop iteration exception gets raised. This is how for loops work underneath the hood in Python. And this is a really good blog post by Trey Hunter about how for loops work. So if you want to get a better understanding of this, I would highly recommend checking this out. There's also a link to this in the references at the end of this talk. So going back to adding the dunder iter to our cart object, So we realized that we need to make our cart object an iterable. And to do this, we would need to add an implementation for dunder iter to our class. Here, I've written dunder iter as a generator function. So when this gets called, it returns a generator object, which is an iterator. So we'll be able to go over each element within this cart container. Taking a look at how this gets used, when I create an instance of the cart and I add some items into it, I can simply use my cart item I can simply use my cart object in a for loop like this, and you see that all the keys that I've added into my cart get printed out. There's also many more methods that let you emulate container types. For example, you can provide implementations for dunder get item, which will let you access a particular element in a container corresponding to a key, and you can find like similar methods for dunder set item and dunder del item. There's a link to the documentation here if you go to the slides, and there's also a link to the documentation towards the end of the slides. We'll now look at some abstract base classes in the collections module. The use case that we are interested in is that they offer some free functionality if your classes inherit from some abstract base classes within that module. Before we get to that, one of the primary use cases of abstract-based classes is to check for interfaces. So if you want to check if your object provides the behavior of a sequence or of a mapping or of something that's hashable, you would use these abstract-based classes. Let's take a look at an example. So here I'm importing ABC from the collections module, and you can see that when I'm running is instance of a list object with the sequence abstract-based class, we evaluate to true. Similarly, a dict object and an abstract-based class of mapping, we evaluate to true when we are calling the isInstance function on it. And when I'm checking if a list object is hashable, we evaluate to false because lists are mutable, and because of that, they can't be hashable. And you would see the reverse of that for string objects where we evaluate to true. So going to the use case that's of more interest to us, inheriting from some of the abstract-based classes gives you free mixing functionalities. So for example, if you inherit from the sequence abstract-based class and you provide implementations for dunder get item and dunder len, you will get implementations for dunder contains and dunder iter automatically added to your classes. Since we've been treating our cart object as a mapping, here you can see that I am inheriting from the mapping abstract-based class. I provided the implementation for dunder iter, dunder len, and dunder get item. We saw most of these already earlier. And with that, when I create an instance of the cart, and when I'm adding some items into it, I can do things like this. Here you see that I'm doing membership checks, even though I've not explicitly provided the implementation for a dunder contains. And here you can see that I'm calling the .keys function on this object, even though I've not provided any implementation for it. Similarly, I'll also be able to call .values or .get on this cart object because I've inherited from that abstract-based class. Here's a link to some more abstract-based classes. There's like many abstract-based classes that offer you free implementations if you inherit from them. The last thing we look at are context managers, which are one of my favorite parts of Python. They're represented using a with statement, and you might have already seen them in the context of opening files or maybe of acquiring a lock. Let's use an example of opening a file and reading its contents, since that's probably a use case that's familiar for many of us here. So if I were to read the contents of a file, here's one way I would do it. I can pass in the path to the file to the built-in open function and get a handle to the file. And within the try block, I would read the contents of the file. And within the finally block, I would close the file handle. Note that I have to do this within the finally block because I have to ensure that the handle to the file gets closed even if there is any exception that gets raised within the try block while reading the file. An alternate to doing it would be to use open as a context manager. So you could do something like this. So here, if I use open as a context manager, I can read the contents of the file directly within the scope of the with function and not take care of and not take care of like closing the handle to the file, because all that gets because the file handle gets closed automatically by the open context manager. If you were to define your own context managers, you'll only need to define these two magic methods, dunder enter and dunder exit. Once you provide these implementations, you can use your class, you can use your object as a context manager. Code within the dunder enter magic method gets executed as you enter the context of a with statement, and code that is inside the dunder exit magic method gets executed when you leave the context of a with statement. Let's simulate the open context manager. So here we are just replicating the behavior for the open context manager that we saw earlier. Here within the constructor, I'm assigning the file name passed in to self.filename, and I set self.filehandle to none. In dunder enter, I'm opening the I'm getting a handle to the file by calling the open function, and I'm returning the file handle here. The value returned by dunder enter is what gets associated with the variable preceding the as keyword in the with statement. Here in dunder exit, I'm taking care of closing the file handle. So any code within this gets run even if there is an exception that gets raised. So here you're seeing that there's also some information available about the exception if an exception got raised within the context of the with block. Taking a look at how it gets used, like here you see that I'm using file reader exactly as I was using the open context manager. I'm opening it and reading the contents of the file within. If you are implementing your own context managers, I would recommend that you look at this context lib.context manager. So context manager is a decorator which makes it super easy for you to write your own context managers in a less verbose way. So you don't have to provide a dunder enter and dunder exit, and instead you can write your context manager as a plain Python function, which is actually a generator function with exactly one yield statement in it. Any code that is before the yield statement can be treated as the code within the dunder enter magic method, and any code that is after the yield statement acts as code that would have been in the dunder exit magic method. So to recap, we enumerated over 3 groups of magic methods. Some of them which let us customize our object's behavior. We saw some that let you emulate container types, and we saw some that let you enable operator overloading. We also saw a quick look at how iteration works in Python. We saw that we can get some free functionality by using abstract-based classes in the collections module. And finally, we saw how easy it is to write our own context managers by just implementing a couple of magic methods. Here's a link to all the resources, and you can find this when you go to the slides at bit.ly/magic-of-Python. The first 4 are blog posts, which are really informative, and I highly recommend checking out if you want to know more about how magic methods work in Python. Also, a quick thanks and shout out to my friend Alex and my colleagues from Venmo who are here. And with that, thanks.